And away we go. Assignment 3C. 3C for AP Calculus, the power rule. This is what we were talking about last week. The power rule is, in general, this. This is what the power rule is. It's the concept that if I have an exponent on something, x to the third, okay, if that's my function, my derivative, that drops down as a multiple, so 3x squared. And even if there's like a number up front, 5 is, so if we have, like 3x to the fifth, okay, the 5 drops down, multiplies, so that's 15x to the fourth as the derivative. It can work the same if it's, what if we have the square root of x, okay, the square root of x, or aka x to the 1/2. All right, well, the derivative, okay, again, it drops down as a multiple, and then you subtract 1. So this would be negative 1/2. Okay, or in other words, cleaning that up, that'd be 2 square root of x as the denominator. Right? So it works that way. It works with negative exponents. So f is equal to 3x to the negative 4, or something like that. Okay, it drops down as a multiple, so that's negative 12x. And then minus 1 is negative 5. So that's the power rule. That's again, and that is 95% of calculus. That's 95% of doing derivatives right there, is just basically understanding the power rule. And so here we go. Use the rules of differentiation to solve this stuff. So the derivative of a constant is equal to 0. Here, basic power rule, 7 drops down, subtract 1. Okay, in addition, what they're just saying is take a derivative of each piece. So in addition, you can absolutely do the addition, but you got to do the derivative of each piece as you go along the addition. So derivative of x is 1. Derivative of 11 is 0. So that's 1 plus 0. F prime of t drops down, multiplies, reduces by 1, drops down, multiplies, reduces by 1, and then the 4 goes away. So again, this is what I'm talking about. I'll split it up a little bit so you can maybe a little bit better understand. So the first thing that happens is that front number drops down and multiplies. So 2 coming in, so that's a negative 6. And then you minus 1, so that's t to the 1, or aka t. Here we already have a t to the first power. So the first thing that happens is it drops down and multiplies. So that's t, or excuse me, 2. Minus 1 is a 0. So a t to the 0th power, aka it's not there. And then here, a constant, the derivative of a constant is 0. So this would be like a minus 0 at the end there. So that is kind of a breakdown of what I'm saying. All right, number 15, the derivative is 2 drops down, goes to 1. 3 drops down and goes to a 2. Here we go. 3 drops down, it turns into a 2. 2 drops down and turns into a 1. The 1 drops down and the t goes away, and 8 is now a 0. Okay, determine where there's a horizontal tangent line. Okay. So, I have some graph. Now, anywhere you look on this particular graph, because it's differentiable, you can take a tangent line. I can take a tangent there, take a tangent there, take a tangent there, and 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 you get the idea. You can draw a tangent line anywhere you want with respect to that single point. Okay, you can draw a tangent line. What a derivative is the slope of those tangent lines. All right, so if this is y is equal to 1/2 x, plus 4, the derivative will give you the slope of that tangent line. Okay, that's what a derivative does. Okay, now this question is asking what x values will give you a horizontal tangent line. Where is there a tangent to this graph that is physically horizontal? A slope. What is the slope of a horizontal line? The slope of a horizontal line. The slope of a horizontal line is y is equal to 4 or something, or aka 0x plus 4. That's a horizontal line. So the slope of a horizontal line is 0. Now, these are going to be incredibly important going down the road, because where do horizontal tangent lines occur? They occur at maxes and mins of things. They occur at maxes and mins. That's where you're going to have horizontal tangent lines. Otherwise, the tangent line is not horizontal if it's anywhere but a max and min. So where is a horizontal tangent line, aka where is the derivative, the slope of that tangent line, equal to 0? All right, so 59, y prime is equal to 4x to the third minus 4x, and then the 3 goes away. All right, so where is this derivative, the slope of the tangent, equal to 0? That will be a horizontal tangent line. So I can factor out a 4x, which leaves an x squared minus 1. That is the same thing as saying 4x, x plus 1 minus 1. And thus I will have 0, -1, and +1 as my horizontal tangent x's. Those are the x's which they're, okay, those are the x's. I'm not sure how specific they really want. They say determine the points. So finding the x value is usually good enough, but if they want to know what is the actual point, what you do is you plug back into the original equation, and that will be the point in which there will be a horizontal tangent line. So -1 is +1, +1 minus 2, -1, -1 plus 3 is 2. 1 is 1 minus 2, which is -1, -1 plus 3 is 2. Those should be your horizontal tangent points. All right, y is equal to x to the -2. Thus, my derivative is equal to -2x to the -3. And where is that going to be equal to 0? So I need -2x to the third equal to 0, and that doesn't happen. Right? That doesn't exist. 0 is equal to -2. That doesn't exist. Nothing will make it. So there aren't any horizontal tangent lines. So if I graph this, you should probably be able to see it. Yeah, that will never be horizontal. You'll never have a horizontal tangent line ever, ever, never, ever. Find the second derivative. Find the second derivative. Okay, so to get a second derivative, we have to start with the first derivative. So that's 2x plus 7. 4 goes away. And thus, the second derivative of this is the derivative of the derivative. So the second derivative is equal to 2. So 6. Okay, so that's the first derivative. Second derivative. Something like that. I'll take that answer right there. I like this answer. So again, they're just asking, what is this higher order derivative? So right now, they start you off with the derivative, and the question is, what is the second derivative? So that's the derivative of what they gave me. Again, they gave me a third derivative, which is, third derivative is 2x to the 1/2. Thus, the fourth derivative, I think usually they write in Roman numerals, but here they just said fourth. Fourth root would be 1/2 times 2 is 1, and then minus 1 of that exponent, so that's negative 1/2. So this is something like that. Again, I'm not exactly sure which answer they want, but that is the fourth root. Is that it? Man, it's easier than I thought. I thought this was going to be a long, tough one. All right, so again, what we're dealing with here is big time the power rule. So again, the exponent drops down, multiplies whatever's up front, and then minus 1. That is the power rule. If you have to rewrite the problem to make it easier for yourself, do that. All right, have a good day, everybody. Keep smiling.